So, hello and welcome to Rational Expressions Lesson 9 for Shaughnessy class. Standard disclaimer, please make sure that you're attending class. There are further examples and further explanation in the class period. These are just designed to be an introductory kind of review session. So, long story short, we've been talking about rational expressions. They are essentially polynomial fractions. So we've got where we've simplified them. We've looked at non-permissible values. We've multiplied, divided, added, and subtracted them, all while making sure we remember the non-permissible values of these things. In this question here, what I want to do is solving a rational equation. So what's changed now is instead of just playing with algebra and saying this is what the sum is, this is what the difference is, this is what the product is, or quotient is, now I'm going to give you an equal sign. Now I'm going to ask you what value of x makes this equation true. Okay, now you still need to consider the non-permissible values. You still need to add, subtract, multiply, divide. But nonetheless, this sort of idea is now looking for what value of x makes this equation true. Because we're leading slowly up towards the ones where we are solving problems. So I'll turn that light off. Hopefully that works. So this notes here, step 1. Find the lowest common denominator for the equation and the NPVs. There was a little bit of a typo. I dictated to Siri. I didn't notice till just now. Okay. Step 2. Adjust. Not adjust each term of the equation on both sides so that they all have the lowest common denominator. Okay. Third, what we're going to do today, there's a variety of ways to do this. I'm going to use something called mystical magical. Okay, it's, at least that's my term for it. Basically, once we have it all over the common denominators, we ignore the denominator. Okay, basically we're multiplying by the denominator, and whatever I do to one side I have to do to the other, so really it cancels out. I'm just going to cross it out. It's going to look mystical and magical. There's not much really that's interesting going on. Basically what happens is then I solve what's left, and once I've solved what's left, then I have to check it against the non-permissible values, because you could have something called an extraneous solution. Extraneous essentially means the algebra, you've done all the algebra correctly, you've got an answer, just the answer doesn't work for whatever reasons. It's extra. So, long story short, you may have extraneous solutions. You must visibly reject that solution. I would recommend just put a line through it. Then I've visibly rejected it. Okay? It doesn't always happen, but nonetheless we've got that idea. So looking at a variety of different examples, i.e. this is all this class is examples. I'm trying with this light. The lighting looks a little odd today. If I give you the equation 4/3 equals 12 over x, and I want you to solve, the question's going to say solve this. Okay, so I look at this, and the first thing I do is I look for the common denominator. So common denominator here, the number is 3 and an invisible 1, so the common denominator of the numbers is 3, as well as I've got an x, so 3x is my common denominator. I'm also going to look at the NPVs. 3 can never be 0, so I don't need to look at that. Here I get x can never be 0, and there's nothing to solve for it, so that's my NPV. It better not be 0. My solution, after all is said and done, better not be 0. So now looking at this, what do I need to multiply to 3 to make it the lowest common denominator of 3x? I multiply to x to the bottom. Whatever I do to the bottom, I have to do to the top. Here I multiply 3 to the bottom. Whatever I do to the bottom, I have to do to the top. So what I'm going to end up with is 4x over 3x equals 12 times 3 is 36 over 3x. Step 3, mystical magical. There we go. I'm not looking at those denominators. So I'm just going to get the equation 4x equals 36. That I can solve. We've been doing that since grade 6 or 7. Divide both sides by 4, divide by 4. I'm going to get x on this side. 36 divided by 4 is 9. There's my solution. I check it. I got 9. Is 9 0? No. So that sounds good to me. Provided I've done my work right, that is the solution. And this is what's going on. The only issue is it just gets more and more convoluted as life goes on. If I look at this one, i.e., okay, x over 3 equals 2 over x plus 1 over 3. Okay, I start the same way. Lowest common denominator. Well, the numbers are 3, 1, and 3, so the number part is 3. There's an x, so I'm going to put that x. So my lowest common denominator is 3x. From this one as well, that denominator is never 0. This denominator could be 0 if x was 0, so x can't be 0. This denominator can't be 0, so I don't have to worry about it. Basically, this starts off looking exactly like the last question, but I promise you it doesn't stay that way. So out of here, to make x, or to make 3x, I'm going to multiply by x. Here to make x, 3x, I'm going to multiply top and bottom by 3. Here to make 3x, I'm going to multiply top and bottom by x. And what I end up with is x times x is x squared over 3x equals 2 times 3 is 6 over 3x plus x times x plus 1, the x distributes through, I'm going to get x squared plus x over 3x. Now that that's done, mystical, magical, boom, gone. I don't need to consider the denominators. So what I'm going to end up with is x squared equals 6 plus x squared plus x. I look at this, this looks like a quadratic equation from Math 20, -1 or -2. So I'm going to try to put the x squareds together. So I'm going to subtract the x squared, subtract the x squared, and what I end up with is 0 on the left equals 6 plus the x squareds are gone, x on the right. In this case, I'm going to subtract the 6, I'm going to move it over. So I get -6 equals x. There's my solution. Last but not least, I check it against my non-permissible value. It's not a non-permissible value, so provided I did my work right, this is a legitimate solution. And all that's happening is we just look at more and more examples of these particular things. Okay? So solving rational equations, if I give you one that looks like this, 3 over x minus 2 equals 5 over 2x plus 1, okay, using what we have from binomials, okay, or from adding and subtracting, I'm going to factor these denominators if possible. So I check. There's no factoring that can be done in either of those. So once that's done, I'm going to find my lowest common denominator. My lowest common denominator is going to be an x minus 2, because that's here, and a 2x plus 1, because that's here. Okay, looking at my NPVs, I'm going to get x minus 2 cannot equal 0, so x cannot equal 2, and I'm going to get 2x plus 1 cannot equal 0, so 2x cannot equal -1, so x cannot equal -1/2. Okay, so those are my NPVs. Now I'm going to work it out. Here I need the 2x plus 1, top and bottom. Here I need the x minus 2, top and bottom. I'm going to end up with 3 times 2x plus 1 over my common denominator equals 5 times x minus 2. And if you see the solution, you can make it a little bit simpler. You could skip a step if you want, provided you don't make a mistake. Okay. Oops, that's a 2. It just doesn't look like one. Okay. Now mystical, magical, those disappear, and I end up with 3 times 2x plus 1 equals 5 times x minus 2. These I've been solving since grade 8 or 9. That 3 goes in, that 5 goes in. I'm going to end up with 6x plus 3 equals 5x minus 10. I'm going to subtract the 5x. I need to pick a side for the x's, so I'm going to put them on the left. That's gone. I'm going to subtract the 3. That's gone, but whatever I do to one side, I have to do to the other. 6x minus 5x is 1x. Negative 10 minus 3 is negative 13. So there's my solution. Last but not least, I check it against my NPVs. Negative 13 isn't 2, and it isn't negative 1/2. So provided I did my math right, it is correct. Okay, and so I can keep going with those things. Now there are other things that can happen with these, e.g., okay, look at this one. Here's some odd things that happen sometimes with these. Okay, you look at this. Well, this is 2 over 1. Remember that that's over 1. Okay, you try to factor. The denominators are factored. So I'm going to look at the numbers, which is 1. My other binomials, which is x plus 1. So my lowest common denominator is going to be 1 times x plus 1. Looking at my NPVs, I get x plus 1 cannot equal 0. So x cannot equal negative 1. This denominator can never be 0, so I don't have to worry about it. So I look at that. Then I say, okay, what do I need to multiply to this to make it x plus 1? The answer, I don't. So I leave it. Here I multiply by x plus 1. Whatever I do to the bottom, I have to do to the top. Okay, so I'm going to end up with 3x plus 3 over x plus 1 equals 2 times x plus 1 over x plus 1. Mystical magical, boom, they're gone. I'm going to get 3x plus 3 equals, here this 2 goes through, 2x plus 2. Subtract the 2x. I have to pick a side, so I'm going to put it on the left. Those are gone. Here I'm going to subtract the 3, subtract the 3. Those are gone. So I'm with 3x minus 2x is 1x. 2 minus 3 is negative 1. Now I check it against my NPVs. Oh goodness. I've got an NPV for this solution. It's not allowed. I must visibly reject it. I usually put a line through it, scratch through it, an X through it. And often, if you're talking to me, I write extraneous solution. I like that term. I want to make sure I use it. It's something that it really sounds like I know what I'm doing. To the marker, it makes it look like, oh, you know, this guy's smart. He knows that word. But also, too, I want to make sure that I'm comfortable with using it. So that's an extraneous solution. So what I get, basically, is I got one solution, had to throw it away. It was extraneous. There are no solutions. So essentially, I did all this work for no reason. There's nothing left over. But I need to know that there's no solutions. So that's the correct answer. The correct answer is there is no answer. Okay? It's not leaving it blank and assuming, well, you know, I didn't do it because I thought maybe there was no solution. No, I'm communicating to the person who's looking at my work or to whoever's evaluating me that I recognize that there's no solution to this equation. Now, all that happens is you just end up with more and more complicated ones. Now, before I do, I'm going to write this. Review the quadratic formula. In Math 20, either dash 1 or dash 2, you did the quadratic formula, which is essentially when you get a quadratic, 0 equals ax squared plus bx plus c. It has to be a power of 2 remains. There's an a value, which is the coefficient in front of it, a b value, which is the coefficient in front of a power of 1x, and c, which is the constant term. If you're going to solve this, there are a variety of ways to do it. You can do what's called completing the square, you can factor if it's possible, but essentially the quadratic formula tells you that the solution x is equal to negative b plus or minus the square root of b squared minus 4ac. All of that divided by 2 times whatever the a value is. This formula is on the formula sheet. Okay? And so if you forget it, don't worry about it. I mean, math teachers, we remember it. I'd argue that it's poetic. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. But truly, doesn't matter. So if you get a quadratic, okay, that looks something like this. Negative 2x squared equals 5x minus 7, and I want to solve this one. There's going to be some sort of wonky decimal. In fact, probably I should do a different one, but nonetheless, this is going to be a wonky decimal. I look at this, and the first thing I should say from my Math 20 is, hey, this is a quadratic. And to solve a quadratic, I need to get it 0 equals. So I'm going to put this 2x squared, I'm going to add it to both sides, so that it cancels out here and I get 0 on that side. And on this side, I'm going to get 2x squared plus 5x minus 7. Now from there, I use the quadratic formula. So I know the solution is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I plug in the solutions. b is 5, so it's negative 5. Plus or minus the square root of b is 5 squared minus 4 times a is 2 times c is negative 7, all divided by 2 times a, which is 2. So I get that. Now this one's working out to be a nasty decimal, I think, but nonetheless, all is said and done. So x equals negative 5 plus or minus the square root of, and I just figure this out. 5 squared, 25, minus 4 times 2 times negative 7. Truly, I just do it in here. So I'm going to end up with 5 squared minus 4 times 2 times negative 7. It's going to be the square root of 81. Oh, look at that. This one works out nicely. All divided by 2 times 2, which is 4. Square root of 81. You may or may not know that immediately that's 9. So I'm going to get x is equal to negative 5 plus or minus. I do the square root. It is 9. So notice I don't have the square root anymore. All over 4. So it tells me that one of the solutions is negative 5 plus 9 over 4, which is negative 5 plus 9 is 4. So it's 4 divided by 4, or 1. There's one of the answers. The other answer is negative 5 minus 9 over 4, which is negative 14 over 4, which is negative 7 halves, or negative 3.5. So there are my two solutions. Now this is a review of the quadratic formula. My reason for bringing this up is because sometimes when you're working with these, you end up with a quadratic. Okay? And you need to remember how to solve those. So we've reviewed the quadratic solutions. Now let's look at one more rational equation. Okay? E.g., I'm going to give you 2x minus 2 over x minus 3 equals x minus 4 over x minus 5 plus 1. Okay, I may end up with a quadratic here, I may not. But if you do, you have to remember how to solve them. So looking at this, find my lowest common denominator. There's a 1, there's an x minus 3, and there's an x minus 5. Okay, looking at my NPVs, I get x minus 3 can't equal 0, so x can't be 3. And I get x minus 5 can't be 0, so I get x can't be 5. So those are my non-permissible values. Looking at my rational expressions, here I need to multiply by x plus 5. Whatever I do to the bottom, I have to do to the top. Here I need to multiply by x minus 3. Whatever I do to the bottom, I have to do to the top. Here I need to multiply by both x minus 5, x minus 3. Whatever I do to the bottom, I have to do to the top. So after all is said and done, this is going to be hard to write out. I get 2x minus 2 times x plus 5 over my common denominator equals, I'm going to get x minus 4 times x minus 3 all over my common denominator That's a minus, that's a minus, this is a minus. I apologize, I'm writing something wrong, so these are minuses. These are minuses, and I'm going to end up with x minus 5, x minus 3 all over my common denominator. And at this point, I may be tempted to give up, but please don't, because you can solve these. Now mystical magical, that's gone. So I'm going to end up with 2x minus 2 times x minus 5 equals x minus 4 times x minus 3 plus x minus 5 times x minus 3. I'm going to FOIL all these out, or multiply all these out once again. If you don't understand what I'm doing, please come and ask. I'm going to end up with 2x squared minus 10x minus 2x plus 10 equals, here I'm going to end up with x squared minus 3x minus 4x plus 12. Here I'm going to end up with x squared minus 5x minus 3x plus 15. So I'm going to get, and I'm just going to clean this up a bit, 2x squared. If I put those two like terms together, negative 10 minus 2 is minus 12x plus 10. Here, putting that together, I'm going to get x squared minus 7x plus 12. And here, I'm going to get x squared minus 8x plus 15. Cleaning this up a little bit more, 2x squared minus 12x minus or plus 10. There's nothing to do there. Here I get x squared plus x squared, so I'm going to get 2x squared, sorry. Here I get negative 7x plus negative 8x. Negative 7 plus negative 8 is negative 15x, and 12 plus 15 is going to be 27. I've got a quadratic, so I'm going to try to put it all to one side. I'm going to put it all onto the left, purely because I need to pick one. So I'm going to subtract the 2x squared. That's going to go. I'm going to add the 15x. That's going to go. I'm going to subtract the 27. That's going to go. And what I'm going to end up with is 2x squared minus 2x squared is 0x squared. I'm going to put it in dotted here. So my quadratic canceled out. If it didn't, I'll have a quadratic to solve. Same deal. Here I've got 12x plus 15x is 27x. Here I've got 10 minus 27 is negative 17, and that equals 0. Oh, sorry, that's negative 12 plus 15. Negative 12 plus 15, I apologize, is 3. Negative 12 plus 15 is 3. So I get 3x minus 17 equals 0. That's linear, so I can add the 17 over. So I'm kind of undoing what I did, but all well. 3x equals 17. Divide by 3. I'm going to get x is 17 thirds, which is I'm stuck for numbers. 5.6 repeating. Okay, so I end up there, and that's what I get. 5.6 repeating. I look at that. Is that a non-permissible value? The answer is no. So that would be my solution, provided I've done my math right. Now, admittedly, I'm just kind of double checking that. Just because it just seems odd to get a decimal. I don't know why. But decimals are okay. So I'm going through. I don't see any mistakes, at least not right now. That's generally how to solve a rational equation. You will be asked to do this. Please make sure that you can. Go through the homework. Make sure you do the homework. Make sure you get the answers. If you need any help, please let me know. And otherwise, best wishes.